All right, welcome back to Hayes' World of Math. I'm glad you could join us. We are talking through some of the questions, so the free response questions from the AP exam. We're in CED Unit 3. We're collecting data, and so I want to talk about 2022's free response question number 2. I think it's a good representation of what we've done. As always, all of this stuff can be found in the link below. I've got a 3-week stats course there, a review course that you might be able to find helpful. In addition, there's also playlists that will go through a bunch of these things. So dermatologist is going to conduct an experiment to investigate effectiveness of a new drug. They recruit 36 pair of identical twins. Each person in the experiment has acne, and each experiment will either find out, everybody in the experiment will either get the new drug or a placebo. And they're going to take it for 2 weeks, and the dermatologist is going to evaluate on a scale of 1 to 100 how much their acne had improved. First part, very basic to get a 1 on this. You have to identify the treatments. So the 2 treatments are either the people get a new drug for the acne or it's a placebo. For the experimental units, 72 people are assigned. Now you can say 36 pairs of twins, but 72 people are receiving the new drug or the placebo. And then again, what are we looking for the response variable? What should change? And that is going to be improvement in our acne. Okay, so those are those 3 parts there. Pretty straightforward. Now each twin has a severity of acne similar to that of the other twin. So however, the severity can differ between sets of twins. So then they ask us, what's the advantage of using matched pairs? Okay. So first of all, obviously, since they're twins, they're going to have acne can be affected by environment and food and genetics, etc. So by having twins and having them have similar genetic background, but since the severity of the acne is the same or similar, it should allow the mean improvements to be more accurate because you have basically somebody who has the same type of acne almost guaranteed in both groups. And so one group's getting a placebo, one group is getting the drug, and so you should be able to see what the mean improvement is all of it. You could even do a difference of mean or a mean of differences if you wanted to, but either way, you should be set for that. Now, lastly, they come on and ask us, and this is one of those things where I found, well, I'll explain afterwards. How are we going to determine which twin gets what? And this is actually pretty straightforward. So, and there's variations on this, which I'll talk to in a minute. For each pair of twins, assign one of them as twin A and twin B. You can say twin 1, twin 2. You could do something even first one in. The oldest of the 2 is twin A, however you want to do it. You can use a random number generator to assign a treatment to twin A. So if it comes up a 1, twin A gets a placebo. If it's a 2, they get the new drug. And then you give the other twin whatever's left over. Now you can flip a coin here. You can have them reach into a bag where there's only 2 choices. However you want to do it. But basically what it amounts to is that you assign twins a number or name. You randomly choose one of them. And then the other one gets whatever's left over. Now, the one thing I'm going to point out about this thing is notice this whole page is empty here. And the thing about that is sometimes my students want to fill this whole thing up. And you don't have to do that. They give you more room for a bunch of reasons, partly because if you're writing in pen, you may not be able to erase it. Also because they can't start another problem on it. So don't feel compelled to go ahead and put all of this in, to fill all of it in. Now, if you want to go through some more stuff in CED 3, up over here is going to be the playlist for that. Down over here is a different playlist from a free response setup. And hopefully you'll find it useful. So we'll see you next time.